Hello and welcome to a new video with Math with Sarah. Our topic today is limits. I will start by putting this informal definition of a limit. Let's read this together. So we say limit of a function f of x as x approaches a equals b. This means when x approaches the value a, f of x approaches the value b. Let's take an example to explain this definition. If I'm trying to find the limit of x plus 2 as x tends to 1, so my function is x plus 2, a is 1. What does this actually mean? So I'm saying x approaches 1 or tends to 1. This means x is going to take values that are closer and closer to 1, but it will never take the value 1. So if I'm thinking of a number line, and I have the value 1 here, I'm trying to take values that are coming closer and closer to 1. So if I'm approaching 1 from the right side and taking values bigger than 1, it's like me saying I will start at 1.1, then move closer to 1.01, and so on. And I can do the same thing and approach 1 from the left side by taking values that are smaller than 1. So let's say I would start with 0.9, 0.99. I'm not interested in the value 1. When I say x approaches 1, this actually implies x will not take the value 1. So if I go back to my definition, x approaches a means x will be close to a, but it will never take the value a. So this is not what I'm interested in. I'm interested in the values that are close to 1. To find this limit, I have to evaluate x plus 2 at these values. So for example, x is 1.1, so I will just replace, and I will do the same thing for all of these values, and I will just fill them out quickly. So this will be 3.1, so by replacing, I get these values. These are the values of x plus 2. So if you notice, the values of x plus 2 are very close to 3. Even if I'm not getting the same exact value 3, they are close to 3, and this allows me to say that the limit of x plus 2 as x approaches 1 is 3. Because when x approached the value 1, f of x, which is x plus 2, approached the value b. F of x might take the value b sometimes, that's fine. But what we care about is x will never take the value a. Before I move on, I will also mention 2 more definitions related to this. We will see more examples on these 2 definitions. So if you notice, I can approach 1 from the right side by taking values bigger than 1, and this we call x approaches 1 plus. Or I can approach the value 1 from the left side by taking values less than 1, and here I say x approaches 1 minus. So if I take the number line again, and the value 1, if I'm taking values bigger than 1 and I'm approaching 1 from the right side, I say x is approaching 1 plus. So this actually implies the values I'm choosing are bigger than 1 and still close to 1. And if I approach 1 from the left side by taking values less than 1, we say x is approaching 1 minus. So this actually implies x is less than 1. For our example here, whether I'm approaching from the right side or from the left side, the answer is very close to 3. So both limits are actually 3. So if I'm approaching from the right side, I'm getting 3. And if I'm approaching from the left side, I'm getting 3. And this allowed me to write just limit as x tends to 1 without specifying any side. X approaching 1 can be from the right side or the left side, and in both cases, I'm getting the value 3. Before I move to another example, let's see what this actually means for the graph of this function. In another video, I will discuss finding limits from graphs, but for now, just let's see what's happening in this example. So by sketching the graph of this function, the function is y equal x plus 2. This is a linear function, so the graph is going to be a straight line. The slope is 1, because I have 1x, and the y-intercept is 2. Thus I have the value 2 here, and I was able to sketch the graph. What does this limit look like on my graph? So I'm taking values that are super close to 1. This is x. I'm looking at the x-axis and trying to come closer and closer to 1. I can take values on the right side, or I can start approaching it from the left side. What I'm interested in is the value of y, the value of x plus 2. So for each of these points, I have to check my graph and see what the value of y will be. So let's find, if I locate these points on the graph, whether on the left side or the right side. If I look at the points on the graph and I try to read their y value, so if I go back to this to try to read the y value, I will notice that the values are very close to 3, and thus my limit was 3. You might have noticed that there was a much easier way to handle all of this if I simply replace the x by 1. And that is right. The first approach to dealing with any limit is to try to substitute by the given value. So always substitute first. By replacing x by 1 here, I was able to find the limit.